Hi, welcome to this session on serverless architecture for product defect detection using computer vision. My name is Mohsin. I'm a solutions architect at Amazon Web Services. Let's get started. In this session, I'll be taking you through how computer vision can be applied to industrial use cases and why is quality such an important aspect to manage for manufacturing organizations. We'll have a look at Amazon Lookout for Vision, followed up by a review of a solution architecture for product defect detection using AWS AI and serverless services. And finally, there's going to be a solution demonstration and some resources that you can have a look at for further reading. Computer vision can be utilized across the various stages of industrial processes. Now, manufacturing by its nature is a very complex and convoluted process, starting from production down to assembling a product, packaging, logistics, and then storage of the products. It can be applied to a variety of scenarios from asset management, worker safety, quality assurance, and process control. In this session, I'll be focusing on the quality management aspect of the industrial processes. Within quality management, there are a number of use cases that we can cater to with computer vision, such as automated quality inspection, root cause analysis, reducing product defects, and optimizing yield. Let's first have a look at why quality is such an important aspect for manufacturing or industrial organizations. Now, quality impacts the cost to operations and customers. And many organizations will have true quality-related costs as high as 15 to 20%, as reported by Aberdeen Strategy Research. Now, some customers even go as high as 40%. This is a huge fraction of their sales revenue. So what sort of factors and metrics contribute to these costs? Some of the top metrics include defect rework, scrapping, customer returns, complaints and warranty, and corrective action processes. To give you a reference point, in 2018, US-based manufacturers are estimated to spend about $26 billion in total claims. So managing quality is a very important challenge to solve. So what are organizations currently doing for quality assurance? For starters, there's the manual inspection process, both inline and end-of-line inspection. And though this process is agile and flexible, it lacks in throughput. It has a slower feedback loop. It's a matter of days, hours, or minutes. And then, again, it's prone to human errors, so it could be the results could be subjective or incomplete as well. There are machine vision solutions available as well, and although they're fast and repeatable with a lower cost of inspection and faster feedback loop, but they have high upfront costs. They limit coverage and are inflexible and may need purpose-built hardware or cameras to be able to cater to automated defect detection. Now, this is where Amazon Lookout for Vision comes in. It's a machine learning service that allows you to detect or spot product defects and visual representations using computer vision. Let's have a look at the different stacks that we have for our machine learning services. Now, at AWS, we are innovating on behalf of our customers to deliver the broadest and deepest set of machine learning capabilities, so that builders of all levels of experience can use them and remove the undifferentiated heavy lifting that's required in building, training, and deploying machine learning models. Amazon Lookout for Vision lies within the specialized stack of AI services. So it's completely focused on industrial use cases, and it's been specially designed to cater to such scenarios and use cases. Apart from Amazon Lookout for Vision, there are a number of industrial AI services that are also there. There is Amazon Lookout for Equipment and Amazon Monitron that help you with real-time condition monitoring. There's also AWS Panorama that enables your standard IP cameras with computer vision. But we'll keep the focus on Amazon Lookout for Vision and the automated quality management use case here. Let's have a look at how computer vision can be done at scale and what are the challenges that it presents. And I'll focus on three main areas. To be able to do computer vision and use computer vision, you have to first have access to sufficient images of product defects. Once you have that, you'll need to spend a lot of time in training, validating, and testing machine learning models. Secondly, once you have a model with a traditional on-premises model, you will have to deploy it on some infrastructure that you'll have to manage. That presents challenges with scalability and compute requirements, as well as security as well. And finally, from a maintainability point of view, you will have limited support for improving your machine learning models at the plant or a manufacturing facility. So how does Amazon Lookout for Vision tackle these challenges? With Lookout for Vision, you can create a custom machine learning model with as few as 30 images, and importantly, without any sort of machine learning expertise. You can run your machine learning models in the cloud and even use low resolution cameras for gathering your data and training a machine learning model. Amazon Lookout for Vision can help you train machine learning models and in diverse conditions as well. Finally, your process engineers and quality managers or operators can provide feedback from machine learning models in real time. And thereby it allows you to iteratively and continuously improve the performance of your models. Now, all of this, you don't need to have any machine learning expertise. And also, you don't need to maintain any sort of servers or inference or need to deploy your model anywhere. So what are some of the use cases that Lookout for Vision can tackle? Lookout for Vision can tackle use cases ranging from detecting surface defects to shape defects. It can also help you identify the absence, presence, or misalignment of objects in an image. It can also help you uncover consistency issues, such as in a steel coil or a paper roll. What is a typical customer journey for Lookout for Vision? So we start with gathering the data set or gathering the images, which is known as the image acquisition part. Once we have the images for our defects and normal products, we can upload them to Amazon S3, or we can import them into Amazon Lookout for Vision via its console. The images can be labeled or put in pre-named folders called as normal and anomaly. Once we have the images and the dataset created, we can start model training. Once a model is trained, we can visualize its performance via the console dashboard, which provides us metrics like precision, recall, and F1 score. And finally, once our model is trained and we are satisfied with its performance, we can integrate inferencing into our application via a simple API call. And once we get more and more data, we can work on iteratively improving our model through feedback. Lookout for Vision provides you binary image classification inference result. And once you get that result, it allows the user to make a number of decisions ranging from classification, rating of the product, binning the product, scrapping it, or maybe using the result for investigating a process, and also for improving the machine learning model. So overall, you are able to make your decisions with more accuracy and in less time. Let's take a look at a quick demo. So, as I mentioned, we start with the image acquisition process. So first, we have to gather images for our product. Here we have an image of a defective printed circuit board which has got scratches on its side. There's another image for a printed circuit board which has got bent pins here. And finally, there's another defect here with improper soldering. Once we have gathered our images for the defects, we can get started with creating a Lookout for Vision model. So we start by logging into the AWS console, go to Lookout for Vision service, and we set up we get started with the initial setup, which is creating an S3 bucket, which is going to host our project's artifacts. Then we'll create a project. We give a project name, and then we move on to creating a dataset. To be able to set up a dataset, we first create a folder on S3. In that folder, we can create a couple of folders called anomaly and normal. This will enable Lookout for Vision to infer the label on the images automatically. Now that we have uploaded our images onto S3, we can copy the S3 URI for the bucket, and we go on to Lookout for Vision console and create a dataset. You've got the option to create a single dataset or training and test dataset. In this case, we go forward with a single dataset. We import images from the S3 bucket by providing the S3 bucket URI, and we check on automatically attach labels to images based on the folder. The images have already been placed into anomaly and normal folder, so Lookout for Vision can simply infer the labels by looking at the folder name. Now that we have the dataset set up, let's move on to training a model. Training a model is as simple as just clicking the Train Model button. Once we click the Train Model button and proceed with the next steps, it's going to take some time depending on the number of images we have in the dataset. As soon as the model training is complete, we can have a look at its model performance metrics like precision, recall, and F1 score, and have a look at the test results as well. Apart from this, once we have a model trained and running, we can do trial detections, which allow us to provide feedback so that we can integrate that feedback into a new model version. To be able to do trial detection, we create a new task for trial detection. We select the right model and select the images against which we want to run inferencing. We choose the files or the image files that we want to test against our model. Once the images are uploaded into Lookout for Vision for the trial detection task, we're going to get some results. Looking at once the trial detection task is completed, we'll have a look at the results and we can provide feedback. So we get to know if the model classified those images as anomalous or normal, and we also get their associated confidence score. Now we can verify machine predictions. So we can provide feedback whether the inference results were correct or incorrect. And once we have done that, we can feed this back into the model, into the dataset, and retrain our model. This allows us to improve our model iteratively over time. Finally, let's see how we can work with the AWS CLI or the command line interface. Now, to use the model, we first have to start it. So we can do it via the CLI or the SDK as well. So we start the model first via the command line. There are a number of API or command line interface commands that you can use. So once the model is started, we can run detect anomalies by providing an image and get an anomaly result along with the associated confidence score. Now that we've set up our model and have some context, let's move on to the solution architecture for product defect detection. So we start by establishing our users or personas who are going to be involved in the overall solution. So first up, we've got the camera that has got some compute capability, or a client application that's responsible for aggregating images, collecting them, and then sending them across to the cloud. Then we have our data science or admin users, and their main responsibility is going to be managing training the lookout for vision model and managing its startup and shutdown. We have our business users, and these could be our C-level or executives or our VPs who would be mainly interested in gaining or visualizing those insights from the manufacturing process or the defect detection process. And finally, our quality managers and operators would be mainly concerned about getting notifications and alerts whenever a defect is detected so they can take appropriate actions. At the heart of the solution is going to be lookout for vision, as we have already seen, and we've seen how we train a model with lookout for vision. The data science or admin users can train the model via the console or via the CLI, and they can have a lightweight static website that would allow them to start or shut down the model so that they don't need to access the console directly. Next, we move on to the image ingestion and storage part. Now here, the camera or the client application, once it's captured the image, it can invoke an API via the Amazon API gateway, which can optionally authorize it via custom authorizer Lambda function. And once it's authorized, it can invoke a Lambda function, which would allow it to get a signed URL from Amazon Simple Storage Service or Amazon S3. Now the signed URL is going to be returned back to the camera or the client, and it can then associate different metadata to the image, like a camera ID, assembly line ID, an image ID, or a facility ID, etc. And then upload that image into S3. Once the image lands in S3, it's going to initiate an event notification, which is going to start AWS Step Functions workflow. With Step Functions workflow, there are going to be three different steps. Firstly, a Lambda function is going to invoke the Detect Anomalies API for Lookout for Vision. It's going to take the image from S3, send that to Lookout for Vision to get an inference result. And the results that it's going to get, it's going to send to another Lambda function, which is going to store them in Amazon DynamoDB, which is going to be a persistent store for this solution. Amazon DynamoDB is a highly scalable, reliable, NoSQL key value based store. Once the record is added to DynamoDB, it's going to be sent across to a DynamoDB stream. And from there, a Lambda function, which is going to be a stream reader, it's going to take that record and then enrich it with additional data or process the data to add or modify some values, and then send them to Amazon Kinesis Data Firehose to batch them up. Kinesis Data Firehose allows us to batch together a number of records and send them to S3, which is going to be a data lake for the inference results. From this data lake, business users can use Amazon QuickSight, which is a serverless business intelligence or visualization tool, to build dashboards and analysis to get answers to a number of business queries. Finally, the third Lambda function in our Step Functions workflow is going to send a notification via Amazon Simple Notification Service. This is going to publish a message to a SNS topic, which is going to send an email notification to quality managers or operators who would be subscribed to that SNS topic. We can replace emails with SMS, or you can also hook up your custom application with SNS as well, via HTTP or HTTPS endpoints. And finally, from a monitoring and alerting standpoint, we use Amazon CloudWatch, which allows us to create alarms and dashboards, along with providing a single pane of glass for looking at logs that are generated by our serverless application. So the various Lambda functions that we have here will generate some logs, and we can visualize them via CloudWatch. Importantly, we can also create alarms, such as if the number of defects exceed a certain threshold, our quality managers or operators could be alerted accordingly. And this is how everything comes together. It's a completely serverless solution, and you can get started by deploying it with a one-click CloudFormation deployment. Apart from the visualizations that you need to create in QuickSight, everything else in the solution can be set up via a single CloudFormation set deployment. Let's move on to our demo. So in this demo, we're going to simulate the process of a camera taking images and then uploading them to Amazon S3. And from there, which triggers the step functions workflow, which will detect whether that image is defective or normal. And based on that, it's going to show the results as well as send email notifications. And finally, we can have a visualization via Amazon QuickSight as well as Amazon CloudWatch dashboards. So we start up by logging into our management front end, which would allow us to have a view of the different projects and the different models that have been created. For the purpose of the demo, the model has already been started. Let's take a look at the data set we used in our model. So this is for metal casting products. It's got about 6,000 plus images that we've used for training the model. Moving on to the lookout for vision console. Let's have a look at our data set. As I said, it's got 6,000 plus images, and we've trained a model that's got very good model performance metrics. And now we're going to simulate the process of uploading images via a simple Python script, which is also going to pass some additional metadata like assembly line ID or a camera ID. We've initiated the script and it's uploading the images into Amazon S3. And as these images are added and those event notifications are being triggered, the images are being sent to Lookout for Vision for inferencing, and the results are being stored in DynamoDB. And we'll shortly get email notifications in our email inbox. So here's the first notification. Let's wait for a few more. There we go. So we get email notifications. Looking at the notification itself, we see the image ID, we see where it's stored in S3, what's the date time for the inference result, and the associated confidence score that we get from Lookout for Vision. Now, as more and more images are being processed, these emails are going to pop up. Now, looking at from a monitoring standpoint into the Amazon CloudWatch dashboard, we can see as more images are processed, the processed image count is going to increase, along with whenever a defect is detected, the detected anomaly count metric is also going to increase. And this dashboard is completely extensible, so you can add more widgets to it depending on your requirements. Now, moving on to the Lookout for Vision dashboard in QuickSight. So this is a custom dashboard that a user or a business user can create, which allows you to create a number of visualizations like bar charts, pie charts, so count of records by assembly line or by anomalous or non-anomalous. It can also allow you to create these line charts for tracking the inference results over time, and also distribution of your confidence. So what are the confidence associated with your inference results, high, low, medium, etc. And you can also create heat maps. Now, this is just an example. It completely depends on your business case and scenario, on the types of visualizations you want to create. Now, once we've done with the inferencing, we can stop the model so that we don't incur any sort of additional cost. I hope you enjoyed the demo. Here are a few more resources that you can have a look at. So there's a blog for detect manufacturing defects in real time using Amazon Lookout for Vision that you can have a look at. I also mentioned a solution earlier. So the solution is available on GitHub called Amazon Lookout for Vision Serverless app that allows you a one-click deploy way to set up all the backend or the serverless solution into your AWS account. And there is a reference architecture as well that you can have a look at. Here's a quick view for this. And to add to this, Lookout for Vision now also supports edge inferencing. There's a reference architecture available for it that you can review for further information. So for use cases where you need low latency inferencing or you've got intermittent networking connectivity, you can also train your lookout for vision model and deploy it on edge devices and run inferencing from there. There are a few more resources, blog posts that you can also review. Thank you so much for listening. I hope you enjoyed this session, and thank you so much, Conf42, for giving me the opportunity to speak here.